So 2.2 is where we're gonna start making our idea of a limit a little bit more refined. Now, the thing that we have to be aware of is that a limit, although it's a cleaner and simpler idea than infinitesimals or monads that Newton and Leibniz had come up with, to write down exactly what a limit is still a little bit complicated. So the way that we learn about limits is going to be backwards. We're going to start with an intuitive idea, and then we're going to learn how to use limits, and it's only going to be at the very end that we write down precisely what a limit is. Okay, so what we want to do is start with an intuitive idea for a limit. Okay. All right. Let's suppose I have this function, f of x equal, we'll take something simple, x squared minus 9 over x minus 3. Okay. Let's ask some questions. What is f of 3? Okay. And f of 3 is a little bit problematic, right? If you try to plug 3 into this function, right, I just plug in blindly, 3 minus 3 in the denominator gives me 0 in the denominator. And hopefully at this point in your math careers, you understand that 0 in the denominator is really bad, okay? And in fact, when you have a 0 in the denominator, if you try to divide by 0, somewhere, I don't know exactly where or who it will be, but somewhere on the planet a puppy will die. And that's terrible, right? It's really, really cruel. So you never want to divide by 0 for that reason alone. We have other reasons why you probably don't want to divide by 0, but that should be enough. Okay, but the real problem is, when you divide by 0, you don't get a number, okay? So if I have a quantity divided by 0, this is not a number. Okay, so I don't really have a value for f of 3. This function 3 is not in its domain. All right, so well, all right, that answers that question. So what happens near 3? Okay, what about f of x near x equals 3? Well, I could plug in values that are really close, right? So again, let's make a little table. F of x and f of x, okay? And just like we did before, we can say, all right, I'm going to pick some x values that are a little bit bigger. I could plug in, say, 5. Okay. F of 5 is 5 squared minus 9 over 5 minus 3. I think that comes out to 8. Okay. What happens if I plug in 4? F of 4 is 4 squared minus 9 over 4 minus 3. Okay. 16 minus 9 is 7. 4 minus 3 is 1. Okay, so we do a little arithmetic there. Well, I can't keep going. I can't plug in 3 because we already said that's a problem. But I want to get closer to 3, right? I could plug in like 3.5. And at this point, it's probably a little bit more efficient to, again, just use my calculator.
It's 6.5.
Yeah, it's 6.5. Okay. Well, if you guys are on the ball, then I'll put a few of these on here. What if I do like 3.1 or 3.001? And maybe while a couple of you are computing that, we'll try from the other side. What happens if I start smaller than 3, right? Like 2, 2.9, 2.999. I think I'll get 6.1, 6.001. If I plug in 2 I can do by hand on the screen. 2 squared minus 9 over 2 minus 3. It's 4 minus 9, which is negative 5. 2 minus 3 is negative 1. Negative over negative gives me a positive, so that's 5. And then I can use my calculator and say, oh, okay, this is 5.9 and 5.999. Okay, so now let's look for a pattern, right? We're getting an intuitive idea for a limit. So when I look for a pattern, I can see, we'll sort of divide this up a little bit. I can see when I'm bigger than 3 and getting closer to 3, my f of x values look like they're getting closer and closer to 6. When I'm smaller than 3 and getting closer to 3, my f of x values, again, look like they're getting closer and closer to 6, maybe from a different direction, but they're still approaching 6. So as x approaches 3, and the way that we can write that in math symbols is we can just use a little arrow. X, we use an arrow to say approaches 3. Then f of x approaches 6. Okay. So the way that we can write this in as a limit is we say the limit as x approaches 3 of f of x is 6. And the way that we write that is I write lim for limit. Underneath it, I write what x is doing. X is approaching 3. And then I say, well, this is the limit of what? It's the function f of x. Okay, so put that next. And is 6, so is means equals. Okay, so this means this. Okay, and this is our intuitive idea of a limit. Right? We're looking at what happens to a function as our x value gets closer and closer to something, what happens to the y values.